My name is Piotr Linke. I'm one of the mobility engineers at Palo Alto Networks. I joined 6 years ago, and my main role is basically to integrate our products with network equipment providers like the Nokias and Ericssons of the world. And I'm also working with customers, helping them basically secure whatever they are deploying in terms of mobile networks, whether it's 4G, 5G, or hopefully 6 and 7G as well. With me, there is Edgars and Dizis that you might know already. They are our regional team over here. I'm working as a service provider overlay. Despite the fact that Palo Alto is the biggest enterprise security company, we do have a lot to offer to service providers, especially when it comes to the 5G, because I think we all got to the same conclusion this week that 5G is all about the enterprises and it's not about consumers. No one's gonna pay basically for faster YouTube. We have 50 patents granted and 50 patents pending, more or less, when it comes to the mobile network security. And the first question is, why should people care about security? Usually, it's all about maintaining privacy, which is just encrypt and send packets from A to B intact, on time, according to the SLA, and no one cares if they are actually sending malicious traffic or legitimate traffic. So the enterprises, they do care. Okay, first of all, they care because they have to protect business critical data. So mobile network is not only the way of access anymore, it is basically the place where the data is in transit, okay, business critical data. Then they have to extend the zero trust, okay? There are different types of customers. They are the ones that own the networks, like in US, in Germany, they basically buy the frequency spectrum, and then they deploy networks on their own and try to maintain them. And there are also customers that are basically relying on a managed service. Okay, but still, the enterprises, they have a security goal, which is to enhance, extend the zero trust approach. And then we have time to detect and time to remediate. Okay, so these are two business factors from the security perspective. If you have a security product only behind the mobile network, you only get an incident, maybe information, and an IP address of the mobile device, which is assigned dynamically. Okay, so there is not enough information to basically quickly troubleshoot which mobile device has generated malicious traffic and react, eliminate it, quarantine it, get it off the network so that it wouldn't be able to, first of all, take out the network and then do something to the data center itself. Then why should service providers care? Because we are reducing the risk of the infrastructure, okay? And there are risks. We heard this many times in the last 2 days that 5G is secure by design. It's not. Then protect the telco cloud, whether it's a private cloud or public cloud. We are seeing that the public cloud vendors, they are actually playing now in the 5G space. They are basically offering, let's say, dedicated instances of the public cloud or some sort of an outpost, a platform like Azure PMAC, Google GDCE, or even Snowball, AWS Snowball is actually able to run 5G workloads now. So what are we focusing on? First of all, the user plane security, okay? We basically put a firewall between the radio and the core network. We are able to open up the GDP protocol and we are able to inspect what the mobile devices are actually sending, okay? Why to do it over here? First of all, you can, in real time, identify the mobile device, okay? We can pull out the subscriber ID and we can pull out the IMSI, the serial number of the device, and we can correlate it in one log entry in real time that, hey, we have stopped the malicious traffic against a data center originating from this mobile device with this subscriber ID, with this serial number and this IP address at the moment. Okay, the next thing is network slice security. So there are two types of customers that I'm talking to usually. One of them, they want to have a single security product that will be slice aware. So whenever they are orchestrating a new network slice, the expectation is that it's not going to be just AMF, SMF, UPF, and maybe PCF per slice, but they are also expecting that the security products will follow this. And they will basically also create a dedicated security policy to this particular network slice. IoT security. There are 5 types of customers. I mean, you can ask each one of them, and each one of them will have a different understanding what IoT security means for them. For some, it's more about the logistics, the provisioning, the commissioning. Okay. For others, it's basically trying to enforce the logic of the OT device. For service providers, especially mobile providers, it's about defending the network from IoT devices. Okay? If the IoT device gets compromised, which is easy, we have to remember it's a very simple device with not too complex software capabilities. So don't expect too much when it comes to security. And once it's taken over, once it's in bad hands, it can very quickly take out the network. It can start with the radio, and then it can basically participate in a DDoS attack, signaling storms, and so on and so on. Okay? So mobile service providers, they don't care about, let's say, the logic. They only care about identifying compromised connected IoT devices and just kicking them out of the network. The next thing is MAC security. Again, there are 3 types of customers. The first one, they are basically getting codes, which is just the standard hardware for a server, and then they are building the platform themselves, and then they are bringing the network functions. It could be from one vendor, or it could be, as I call it, a Frankenstein, that they basically bring a little bit of from each known vendor. The second type of customers, they are basically buying everything from a particular network equipment provider. It's like a vanilla end-to-end architecture from one vendor. And then the third type of customers is adopting public cloud platforms. Like I said, Azure PMAC, AWS Snowball Outpost, and Google GDCE. The next issue is the core network security, the network functions. Since 5G is basically based on IT enterprise class solutions like Kubernetes, for example, and then the whole concept of DevOps and so on, then it means that it is also inheriting the same risks, and those risks, they have to be addressed in the same way as in the IT security world. Okay? So if, for example, no one would put a containerized application exposed to the internet, you shouldn't be doing the same with the 5G network functions, okay? Without proper security measures. Those network functions, they are suffering from exactly the same issues, okay? From what I'm seeing is security last, okay? Not security first. Let's make sure that it's working, that it's fully interoperable. Let's make sure that the performance is there, that it's stable, and then we will worry about security, patching, fixing stuff, and so on and so on. Okay? Then the next one is roaming security. We have a lot of projects for roaming security globally, where basically in 4G and 5G, it is only 5% of traffic statistically, but let's say from the risk perspective, it's much more important than just those 5%. RAN security. I think I'm going to have a next session about RAN security and open RAN security, but it's mostly about defending basically the core network from the RAN security, from the RAN segment. The next one is RAN sharing. This is what we are seeing mostly in Asia. The governments are building the antennas, the radios, and then local service providers, they just pop up as MVNOs, 5G MVNOs. And then there is a private network security. This requires a little bit different approach. These networks are much smaller, and basically the enterprises, they are very, very strict. They are actually sending back home all the big guys that recommend service provider grade security instead of enterprise grade security. Okay, so just like our customers, they were adopting public cloud. They wanted our products to be present in the public cloud. They didn't want anything else. And what we are seeing is that the enterprise customers are challenging network equipment providers on the security. And they are expecting that the private 5G networks, they will be also using the same vendors that are well known within the enterprise market. Okay, the next one is the core. Okay, so everybody was talking about vulnerability management. Yeah, that's nice, but there's much more to it. Okay, first of all, it cannot be a one-time thing. It's a constant process. By the time I started this presentation, there were at least 15 new vulnerabilities announced. Okay, so the threat landscape, well, the attack surface has changed a little bit, right? We have new 15 vulnerabilities. If someone scanned, for example, the software network functions a couple of weeks ago, then it's a completely different picture now. Same thing with compliance. Compliance is more like checking if the network functions and the platform are configured and built according to the art of building secured applications. Okay, we have to remember that it's built by the developers. They cut corners. I actually heard yesterday that security is actually an obstacle. Okay, sometimes. Same thing I'm seeing with some customers. If something is not working, the first thing they will do, they will turn off a firewall. Without any troubleshooting, without any thinking or basically checking if it's actually maybe the firewall that is blocking it. CI/CD security, well, all the network functions and all the software, whether it's Open RAN or core network, they have to go through this software supply chain, okay? So it's very important that the software supply chain is actually built as a secure software supply chain, okay? Because this is the place where you're able to stop things before they go in production, to basically stop poor quality software, poorly basically maintained, poorly built, excuse me. Someone was basically, I think, mentioning backdoors. Well, if you look at the vulnerabilities, like for example, Log4j vulnerability that is out there for 4 years now. So let's presume that there is a network function which still has this vulnerability. And you can publicly download an exploit, for example, from the internet. It's not a vulnerability anymore, it's a backdoor. Okay, so we should change the perception a little bit. The next one is runtime defense. Okay, once it's in production, once it's running, we are seeing a lot of strange things happening with network functions. The first thing basically that the NEP engineers are doing when they are, for example, troubleshooting something is they are logging into containers and then they are downloading various tools, like for example, TCP dump, netcat, okay? And then the original secure by design network function is slightly deviating from the original image. Okay, then they do troubleshooting, then they basically leave everything just the way it is. And it is, of course, exposing risks. There's also much more to it, of course. I saw a lot of people talking about only, let's say, vulnerabilities in open source. Okay, but it's not necessarily just an open source that can have a vulnerability. Also, custom-made applications by the software developers, they might refer to open source tools like libraries or maybe a database and so on and so on. But you have to remember that those applications, they have vulnerabilities as well. Who's looking for those? Okay, is anybody doing penetration tests, for example? So the runtime defense will basically give an insights. It's going to give insights into what's going on with the network functions on top of the containerized platform, for example. Okay, if you have a north and south firewall, and then you have two network functions at the bottom inside of a Kubernetes cluster, you're not going to see how they are communicating. What if one network function is hacking another network function? Or it's basically doing something to decrease its performance? Okay, no one has visibility into this today. And then there is API security, which is a really big thing these days. We are seeing more and more requests, basically, about securing the API engine. Okay, it's like, okay, we have to expose a couple of information, like the location of a mobile phone. For example, banks want to know if a mobile phone is roaming when it's doing a money transfer, right? Because it's a higher risk. And so on and so on. And then we have customers who are saying that, oh, we actually have to expose through API the whole network. Okay, so that some maybe government organizations, they will be able to build network slices on their own in a certain area, for example, and we're going to basically lose control over it. So the next problem that we are seeing is, okay, you have network security in place, you have cloud security and virtualization security in place. Now, what do you do with the logs? Okay, like Open Run security logs for the radio part, they can generate, for example, 1 terabyte of data, of logs. Who's going to be looking into it? Who's going to be analyzing that? And who's going to be looking for the needle in the haystack? So you need to hook up basically something that will sit on top of everything, and it's going to do the analytics and correlation. Okay? So for this, we basically, we are recommending to properly build a security operations center on top of network operations center. Okay? Like I said, because 5G adopted the enterprise best practices, the whole concept is very, very similar. Okay? It's just that they are not looking at what's going on with the remote workers or what's going on in the office. They are basically looking at the stability of the network functions, the platforms, and ORAN, for example, and also what's going on with the mobile phones. And then the last bit is the attack surface management. So it's important to basically know what are we exposing, okay, to the internet. So when we hook up basically a network, we can basically expose a couple of things that we didn't necessarily wanted to do. Okay, so it's quite important to constantly scan, for example, from the outside world, a particular organization, a particular network segment, just to make sure that there is nothing popping up that shouldn't be there.